Hello everyone, welcome to a new algebra session. In this session we're going to start Unit 2 by working on the first lesson, which is non-negative and negative integer powers in R. Let's remember that if A belongs to R, which is the set of non-zero real numbers, then A power 0 is always equal to 1. For example, square root of 5 to the power of 0 is 1. Negative 2 square root of 3 to the power of 0 is also 1. Anything to the power of 0 is 1 except 0. From the repeated multiplication, we knew that negative 4 all squared is 16, and also 4 squared is 16. Note that 2 is an even number. Negative 4 all to the power of 3 is negative 64, and negative 4 all to the power of 3 is negative 64, because 3 is an odd number. Negative a all to the power of n is a to the power of n if n is an even number, while negative a all to the power of n equals negative a power n if n is an odd number. As we can easily say that the even power eats the negative, so negative number all to the even power, the negative sign disappears, while negative number all to the odd power, the negative sign appears in the result. If a is a real number and a is not equal to 0 and n is a positive integer, then a power negative n is the same as 1 over a power n, and a power n is the same as 1 over a power negative n. Let's see these remarks. For every a belongs to R and n belongs to Z positive, then a power n times a power negative n is the same as a power n times 1 over a power n, which is 1. Any number multiplied by its multiplicative neutral is always equal to 1. Any number multiplied by its multiplicative inverse is equal to 1. And this is called the multiplicative neutral. As you see here, a power n and a power negative n are the multiplicative inverse of each other. For every a belongs to R and b belongs to R and n belongs to Z positive, then a over b all to the power of negative n equals b over a all to the power of n. If you have a fraction has a negative power, to make this power positive, we can easily flip the fraction. For example, 2 over 3 all power negative 2 is the same as, we flip the fraction, 3 over 2 all to the power of positive 2, which is 3 squared, which is 9, over 2 squared, which is 4. Let's now go to the law of non-negative and negative integer powers in X. If a and b are two real numbers, m and n are two integers, except the cases in which the denominator is equal to 0, and the cases in which both the base and the power is equal to 0. Then, when we multiply while we're having the same base, we add the powers. Like, for example, 4 to the power of 3 times 4 to the power of 2, we do not change the base, which is 4 to the power of, we add the powers, so it's 3 plus 2, which is 5. In the division, if we're having the same base and we're dividing the powers, we do not divide the powers, we subtract the power. Like an example, 3 power 6 divided by 3 power 2, we do not change the base, so it's 3, 6 minus 2, which is 4. If we have two numbers multiplied together and they all have a power, so this power is distributed on both numbers. So 3 times 4 all to the power of 2 is 3 power 2 times 4 power 2. Law number 4, if a over b to the power of n, then this n goes as a power on the a and as a power on the b. So 2 over 5 all to the power of 3 is the same as 2 power 3 over 5 power 3. A power m all to the power of n or a power n all to the power of m is equal to a to the power of m times n. If a power came and stood on a shoulder of another power, like 4 power 2 all to the power of 3, we can say that it's 4 to the power of 3 times 2, which is 4 to the power of 6. Let's now go to exercise number 1. Choose the correct answer. 5 squared plus 5 squared is equal to what? We know that 5 squared is 25, plus 5 squared is 25. 25 plus 25 is 50. Question 2. 5a to the power of 0 equals what? We know that anything to the power of 0 is equal to 1. Question 3. The quarter of the number 4 to the power of 20 is what? A quarter of any number means that this number multiplied by 1 over 4. So it's the same as 4 power 20 multiplied by 4 power negative 1. When we multiply, we add the powers. So it's 4 to the power of 19. Fifth of this number means 1 over 5 multiplied by this number. So it's 1 over 5 multiplied by the square root of the cubic root of 5 all to the power of 6, which is equal to 1 over 5 multiplied by 5, and then here we divide the power with the index of the root, so it's 1 over 5 multiplied by 5 squared. 1 over 5 is 5 power negative 1 multiplied by 5 squared. When we multiply, we add the powers, so it's 5 power 1, which is 5. Question 5. Which of the following is closest to 11 squared plus 9 squared? 11 squared is 121 plus 9 squared, which is 81. The result is 202, which is choice D. Question 6. If 3 to the power of x is equal to 4, what is 3 to the power of negative x? So here, 3 to the power of negative x means that we flip the number. So instead of having here power 1, so it will be 4 power negative 1, which is 1 over 4. Question 7. 2 times 10 to the power of negative 3 multiplied by 5 times 10 to the power of negative 2. Then it is 10 times 10 to the power of negative 5. So it's 10 to the power of negative 4. So the right answer here is choice B. Question 8. Square root of 3 plus square root of 2 all to the power of 9 multiplied by the square root of 3 minus the square root of 2 to the power of 9. So a difference of 2 cubes. This is the same as root 3 plus root 2 multiplied by root 3 minus root 2 all to the power of 9. Difference of 2 squares. So this means that it's 3 minus 2 all to the power of 9, which is 1 to the power of 9. So the result in this case is 1. Question 9. If x equals square root of 9 divided by the square root of 3, what is x power negative 1? If x equals root 9 over root 3, this means that x is equal to square root of 3. So x power negative 1 means 1 over the square root of 3. To rationalize the denominator, we multiply up and down by root 3. So it is root 3 over 3. Question 10. Complete this. X to the power of m minus 1 multiplied by what equals 0. To reach 0, this means that x to the power of m minus 1 times x to the power of something equals x to the power of 0. So m minus 1 plus what equals 0. So here we're going to change the sign of m and the sign of 1. So here it's minus m plus 1. So the right answer is choice D. Let's now go to another type of question, which is simplifying the expressions. In this question, the question wants me to simplify each of the following. So here you can see that we're having a base which is square root of 3. So taking the numerator, when we multiply, we add the powers, and the denominator here as it is. So this one will be square root of 3 to the power of 15 divided by the square root of 3 to the power of 6. When we divide, we subtract the powers. So square root of 3 to the power of 15 minus 6. So this means that it's the square root of 3 to the power of 9. If you want to simplify this more, this means that it's 3 to the power of 4 square root of 3, which is 81 to the power of 3. Question 2, we'll try to make them all having the same base. So in here it will be 10 to the power of 2 plus negative 7 over 10 over 1 over 10 to the power of 2 multiplied by 1 over 10 to the power of 3 because it is a 1000. So in this one, it's 10 to the power of negative 5 over 10 to the power of negative 2 times 10 to the power of negative 3. If we add the powers in the denominator, so it's 10 power negative 5 over 10 to the power of negative 5. Anything over itself, the result is 1. Question 3, we try to make all the bases the same. So in this question, in question 3, the 9 is 3 power 2, all to the power of x, multiplied by 3 to the power of x plus 2, and the 27 is 3 power 3. So this one, it will be 3 to the power of 2x times 3 to the power of x plus 2 over 3 to the power 3x. So here it's 3 to the power of 2x. In multiplication, we add the power. In division, we subtract the power. So it's 3 to the power of 2, which is 9, because 2x plus 2x is 3x minus 3x. They're all crossed out together. Question 4. Let's try to prime factorize the bases. We know that the 4 is 2 to the power of 2. And here the power is x plus 2 multiplied by 9, which is 3 power 2. And the power is 3 plus x. And here the 6 is 2 times 3. And each of them will have a power of 2x plus 3. So this one will be 2. And then we multiply the powers. 2 times x plus 2 times 3. And the power is 2 times 3 plus x over 2 to the power of 2x plus 3 times 3 to the power of 2x plus 3. So to simplify this more, it's 2 to the power of 2x plus 4 multiplied by 3 to the power of 6 plus 2x. And here down, it's 2 to the power of 2x plus 3 multiplied by 3 to the power of 2x plus 3. If we combine the same bases together, it's 2 to the power of 2x plus 4 minus the 2x minus the 3. As if we have a bracket minus open bracket 2x plus 3. The minus goes to every term in the denominator. Multiplied by 3 to the power of 6 plus 2x minus 2x minus 3. So to simplify this, 2x minus 2x is a 0. So it's 2 to the power of 1 multiplied by 3 to the power of 3. So it's 2 times 27, which is 54. By solving this exercise, dear students, we reach the end of our lesson. Thank you very much and see you next time.